In section 6.2, we are adding and subtracting rational expressions. So just like with fractions, we have to have a common denominator to add or subtract rational expressions. So the first thing we're going to look at is if they do have that common denominator, then all we do is we add or subtract the numerators and then write it over the common denominator. So we have x squared over x plus 7 minus 49 over x plus 7. Because I have the same denominator, I can combine the tops together, and I get x squared minus 49 all over my common denominator of x plus 7. Once we have it written as a single fraction, we want to simplify. The top is a difference of two squares, so this can be factored as x plus 7, x minus 7. And the bottom is still x plus 7. But we have x plus 7 on the top and bottom, and so all we're left with is x minus 7. Let's do another one. We have x over 3y squared minus x plus 1 over 3y squared. What you have to be careful of, especially with the subtraction, is that you put the second numerator in parentheses if there is more than one term. So we have x minus x plus 1 in parentheses all over that 3y squared. And then we need to distribute the negative to both pieces. So we have x minus 1 all over 3y squared, but our x's are going to cancel, and we're left with negative 1 over 3y squared. But what if we don't have the same denominator? Then we have to be able to identify the LCD, or the least common denominator, of rational expressions. And so to add or subtract rational expressions with unlike denominators, first write the rational expressions as equivalent rational expressions with a common denominator. The least common denominator is usually the easiest common denominator to work with, but as long as it's common, that's all that matters. You just do a lot less work with the LCD. To find the LCD, you'll factor each denominator completely. And the LCD is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any factored denominator. So let's go ahead and find the LCD of the rational expressions in the list below. M minus 1 over m squared minus 25. Well, we're just looking at the denominator. So m squared minus 25 is a difference of two squares. So we can factor this as m plus 5, m minus 5. 2m squared minus 9m minus 5. Well, that can be factored as 2m plus 1 and m minus 5. And m squared minus 10m plus 25 can be factored as m minus 5 times m minus 5. But that's just m minus 5 squared. So each factor that's unique has to be listed in the LCD. So looking at the first one, m squared minus 25, that means we need to include m plus 5 and m minus 5. In the next one, 2m plus 1 and m minus 5, we need to include 2m plus 1. And we already have m minus 5, so we don't have to write it twice. And then in the last one, we have m minus 5, which is already there. Once we have each unique factor listed, we need to find the highest power that's present for any of them. So m plus 5 is only present once and it has a power of 1. M minus 5 does have a power of 2 in the last one. So that's what we need to raise it to. In 2m plus 1, the highest power is 1. So our LCD is m plus 5 times m minus 5 squared times 2m plus 1. Let's go ahead and do another one. We have x squared minus 4. Difference of two squares, this becomes x plus 2 times x minus 2. And we have 6 minus 3x. And we can factor out a greatest common factor of 3. And we're left with 2 minus x. Now remember, we can multiply this 2 minus x times negative 1 so that it looks like x minus 2. So I'm going to multiply by negative 1 so I can rewrite this so that it looks similar to the one beforehand. So looking at the factors of the first one, we're going to write down x plus 2. We're going to write down x minus 2. Then we look at the second one. I need to write down 3. And I need to write down negative 1. I don't need to write down x minus 2 again because I already have it written in my LCD. The only power that's present for any of these factors is 1, so we don't have to worry about that. But we can make this look a little nicer as negative 3 times x plus 2 times x minus 2. So to add or subtract rational expressions with unlike denominators, we write each rational expression as an equivalent rational expression so that their denominators are alike. So you're going to find the LCD of the rational expressions, and then once you have the denominators as the LCD, you are going to add or subtract the numerators and then simplify the result. So looking at example number 3a, we have 3 over x plus 2 over x minus 2. Well, the denominators are already factored as much as they can be. So my LCD is x plus 2 and x minus 2. So that's what both the denominators need to look like so that we can add or subtract the numerators. So looking at the first fraction, 3 over x plus 2. What part of the LCD am I missing in this denominator? I already have the x plus 2, but I'm missing the x minus 2. And what I do to the bottom, I have to do to the top. So I'm going to multiply x minus 2 on the top and bottom. For the second fraction, 2x over x minus 2. This time I have the x minus 2 part and I'm missing the x plus 2 part. And so again, what I do to the bottom, I have to do to the top. So now my denominators look exactly the same as they should, and we'll be able to combine the numerators. So I'm going to have to distribute the 3, and I'm going to distribute the 2x. So in the first one, I have 3x minus 6, and we can automatically smush this into one fraction because they have the exact same denominator. Plus 2x squared plus 4x. And this whole thing is over my LCD, which is x plus 2 times x minus 2. And so we want to combine like terms. I have 4x and 3x. So writing in descending order, I end up with 2x squared plus 7x minus 6 all over x plus 2 times x minus 2. Well, the next question you want to ask is, can we simplify this? So can I factor the numerator? I cannot. So this is going to be our final answer. You don't have to worry about multiplying the denominator back out. We usually just leave it in factored form. It's easier to see the domain of the function or the expression. Let's go ahead and try the next one. We have 2x minus 6 over x minus 1 minus 4 over 1 minus x. So the LCD, remember, x minus 1 and 1 minus x are opposites. So we can multiply one of them by -1 to make them look like each other. So I am going to multiply the second one by -1, and then we have our x minus 1. So it'll be a little bit easier to see the LCD. Our LCD here is actually just x minus 1. We have 2x minus 6 over x minus 1. But looking at the second fraction, I have 4 divided by -1, which is just -4 all over x minus 1. Well, we have the same denominator, so we can just combine them into one fraction. So 2x minus 6 minus -4 all over x minus 1. Well, we have a double negative on the top. So we really have 2x minus 6 plus 4 is -2 all over x minus 1. Let's go ahead and factor out our GCF of 2. We have x minus 1 left over x minus 1. And so what we can cancel on the top and bottom is x minus 1, and we are left with just 2. Let's try 2 more. We're going to subtract 5k over k squared minus 4 minus 2 over k squared plus k minus 2. The first thing we want to do is we are going to rewrite these by factoring the denominator. So factoring the first one, we have a difference of squares. That's k plus 2 times k minus 2 minus, and then we have our 2 over, factoring the denominator here, this is going to be k plus 2 and k minus 1. So what is our LCD? We have k plus 2, we have k minus 2, and the only piece I'm missing is k minus 1. So both of our denominators need to look like this LCD so that we can combine the numerators together. So looking at the first one, we have 5k over k plus 2 times k minus 2. And so the piece that I'm missing is the k minus 1. And what I do to the bottom, I have to do to the top. For the second one, I have k plus 2, I have k minus 1, and so the piece that I'm missing is the k minus 2. And what I do to the bottom, I have to do to the top. And so we need to distribute the 5k and the -2. So we have 5k squared minus 5k. Go ahead and group the negative with the 2 to make your life easier. So negative 2 times k gives me negative 2k, and negative 2 times negative 2 is plus 4. And this entire thing is going to be over my LCD, which is k plus 2, k minus 2, and k minus 1. So looking at the top, combining like terms, we end up with 5k squared minus 7k plus 4 all over my LCD of k plus 2, k minus 2, and k minus 1. You always want to see if you can factor the numerator to see if we can cancel anything out with the denominator. And in this case we can't, so we're just going to leave this as our final answer. And let's go ahead and try one more. Now we're combining addition and subtraction, but we still need to have an LCD for this to work. So we have 7 over x minus 1, which we can't simplify, plus 10x over x squared minus 1, but that can be broken down as x plus 1, x minus 1, and then minus 5 over x plus 1. And so my LCD in this case is x minus 1 and x plus 1. So in the first fraction, I have x minus 1, and so the piece that I'm missing is the x plus 1. In the second fraction, we already have the LCD, so we don't have to fix this at all. We're just going to rewrite it as it is. And then in the last one, we have the x plus 1, but we are missing the x minus 1. And what I do to the bottom, I have to do to the top. And so what we have to do is we're going to distribute the 7, and we're going to distribute the negative 5, and we can put this all on one fraction. So we have 7x plus 7 plus 10x minus 5x plus 5. And this is all over x plus 1 and x minus 1. So let's go ahead and combine like terms. We have 7x, 10x, and negative 5x. We also have 7 and 5. So 7x plus 10x is 17x, minus 5x is 12x, and 7 plus 5 is 12. All over my LCD. You always want to see if you can simplify the top and bottom. We can pull out a greatest common factor of 12 from the top, and we're left with x plus 1. And on the bottom, we have x plus 1 times x minus 1. And so we can cross out the x plus 1, and we are left with 12 over x minus 1.